there is this giant hole in the Indian Ocean where the sea level dips by over 328 feet on 3 million square kilometers of area. For your reference, the area of Greenland is 2.17 square kilometers. This hole is actually a gravity hole. Scientists have been looking for an answer to that for a long time. Finally, researchers came up with an answer. Let's learn more about it in this video. The scientists from the Indian Institute of Science in Bengaluru, India, used supercomputers to simulate how this gravity hole might have formed. Before we can understand this, we need to understand a few things about Earth's gravitational pull. First, the Earth's shape is not a perfect sphere. It's more like an ellipsoid with a lot of dents and bumps on it. As we can see, the Earth has mountains, valleys, oceans, deserts, and all kinds of shapes on the surface. The gravitational pull is also different because of that. For example, the gravitational pull is much lower on top of a mountain than on the sea level. But even on the sea level, gravitational pull is not the same everywhere. Here is why. Our planet is not homogeneous in terms of density and properties inside the Earth. If you dig down inside the Earth, you will find different densities in different areas. So because of the varying density inside the Earth, the gravitational pull varies on the surface of the Earth. If the density inside the Earth is higher, the gravitational pull is higher, and if the density inside the Earth is lower, the gravitational pull is also lower on the surface. If we can take the tides and currents off of the oceans, it will settle into an undulating surface of water because of the varying gravitational pull I just described. This irregular shape is called a geoid. The gravity hole in the Indian Ocean, which is the lowest point of the geoid, forms a circular depression that starts just off India's southern tip and covers about 3 million square kilometers. This gravitational anomaly was first discovered by Dutch geophysicist Felix Venning-Maines in 1948 while doing a gravity survey from a ship. Atreya Ghosh, a geophysicist and associate professor at the Center for Earth Science of the Indian Institute of Science with her colleagues, ran 19 simulations using computer models with supercomputers to form big pictures geologically from 140 million years ago. The continents and oceans were in many different places 140 million years ago. They recreated the shifting of tectonic plates and the behavior of magma or molten rocks, and layers between the core and the crust. In 6 of those scenarios, a similar geoid low was created by the computer model. From those pictures, they came up with the idea of how this geoid low was formed. From the computer simulations, the researchers came up with the conclusion that this geoid low was formed because of the magma plumes that have a much lower density in that area. The gravity hole is because of the low density of the magma plumes. Because they set the clock back to 140 million years ago, they saw that there was an ocean in between the Indian plate and Asia at that time period. India started moving north and the oceanic plate went down inside the mantle, causing the gap between the Indian plate and Asia to close. When the oceanic plate went down to the mantle, possibly the formation of magma plumes happened and the low-density material came closer to the seabed. As per the mathematical model, this geoid low was created about 20 million years ago. The model was not perfect. There were some events like a volcanic eruption that happened 65 million years ago were not recreated by the simulation. The scientists admitted that there is an 80% correlation between the simulated geoid and the original geoid. But they think that, to find out the reason for the low geoid in the Indian Ocean, the model did a decent job.